I think I'm stalling because I really don't want to take this thing apart. It was so much work to get this together, and I'm not sure it could go back together and get it exactly square like I have it now. I knew this step was going to be a problem, but it was like, this is going to be a problem for future Zach. Hi everyone, my name is Future Zach, and here on Byte Sized Engineering, I make ridiculous projects to get you excited about unleashing your inner maker. I've been building a CO2 laser cutter for over a year now. I'm designing a lot of it as I go along, so often I find myself saying, that's a problem for Future Zach. Well, now I'm Future Zach, and I'm having to deal with all the problems I previously pushed down the road. If you haven't seen those previous 5 videos, I recommend you go watch those first, and you can do that by clicking on this playlist up in the corner. Even though in the last video I got this machine up and running and making cuts for the first time, it's not ready or safe to be using regularly. So in this video I want to complete 3 objectives and bring it across the finish line. Right now I don't have a motorized Z-bed, so anytime I want to make a cut I have to stack up material just to get it the right length away from the laser head to make the cut. This is not going to work. I need to make a motorized Z-bed so that I can bring my material into focus automatically. The second objective for this video is to tidy up all of the electronics. Right now they're sitting in the back of the base cabinet and they're a huge mess. I want to build an electronics panel that I mount everything to so I can clean it all up. The third objective is to improve the safety of this machine. Right now, because it's an open aluminum frame, the laser beam has the potential of accidentally bouncing out and injuring somebody, so it's time to install some panels and enclose the laser cutter. I have something special in mind that I haven't seen anybody else use on their DIY laser cutters. By the end of this video, you'll see this machine transform from a janky DIY laser cutter into a professional looking machine, complete with a motorized Z-bed, an electronics control panel with everything organized, and panels to enclose the machine. The first thing I need to do to build the Z-axis bed that can move up and down is to install 4 lead screws, 1 on each corner. To do that, I've designed and 3D printed some little parts to make that easier. Once I get all 4 lead screws in place, I can cut and install 4 pieces of aluminum extrusion to make the bed. I just finished installing all 4 linear rails and attached them to the rectangle that I built out of aluminum extrusion. That rectangle will obviously be the Z-axis bed that I can raise and lower. One of the issues I ran into while installing these linear rails is that I use these pillow blocks. I got these on Amazon for really cheap and the quality is not great. These pillow block bearings have a ball joint that lets you kind of swivel that bearing inside there. I only had 1 of these in my box of parts, so I couldn't really use it on this build, but this is what it's supposed to do. It's supposed to be able to swivel around like that. While these cheap Amazon ones get stuck, I can force it to move around with a screwdriver, but it's really not smooth and it catches and it's just terrible. I even took one apart and tried to sand it down in the vise and I got it to work a little bit better. I can kind of move it by hand, but this just wasn't really going to work. Originally, I installed a pillow block bearing here on the bottom and then one on the top. And because these don't swivel around like they're supposed to, it just constrained the movement way too much and everything was binding up. So what I think I'm going to do is just leave the top part floating. I'm not going to install one up here. Hopefully the rest of the structure is rigid enough that this will keep its shape. I'm working on installing a motorized Z-bed for my laser cutter. So I've installed 4 of these lead screws, 1 in each corner. And I can't get them to rotate very easily. I think everything's kind of binding up. I'm not sure. I've adjusted them several times to try to get the motion to be smoother. So what I'm going to try next is, instead of just relying solely on these lead screws to hold the bed up, I'm going to install, I just ordered these guide rods. They're kind of smooth guide rods, and so that's what will be providing the mechanical alignment for this bed, instead of the lead screw there on the right. And hopefully that will solve the problem of it kind of binding up. I want the alignment to be entirely relied on these guide rods, and the lead screw should just be in charge of moving it up and down. So hopefully that modification works and I can get this thing moving up and down soon. I've got all 4 guide rods installed and it seems to be doing a lot better, keeping things aligned, and there's not as much binding as there was before, so that's awesome. I ordered some 10mm GT2 timing belt, and I'm going to use that to drive the lead screws up and down. So I need to install some 10mm pulleys instead of the 6mm ones that I already have on there. Once I get the pulley switched over, it'll be time to wrap the timing belt around all of the pulleys and get the motor installed, and then I can test out raising this bed up and down. It would have been nice to have a closed loop belt, but I couldn't find one that was the right size, so I'm just going to use an open belt and then stitch it together to make it closed. It's really important at this step that I get the bed level, because I don't want the bed kind of tilted, so I'm going to spend some time now with the tape measure and get that bed as level as possible. This is the motor mount for the Z-axis motor, and once again I'm dealing with holes and slots that are designed to fit M4 bolts instead of the M5 bolts which I used everywhere else on the machine. So what I'm going to do is drill my own holes at the right spacing at the right size. I want to get these as precise as possible, so I'm going to use a center drill in my CNC machine. I'm not going to use this machine to drill the hole all the way through because it's really not built for that. But what I can do is spot drill the right locations, and then I'll just follow it up on my drill press. I need to create a closed belt in order for this to work. The first idea I had was to kind of glue these two pieces together and then cut a short length of the belt to create like a patch to bring those two pieces together. But that didn't work, and maybe it's because I used regular CA glue, but it just didn't really hold up very well. So I'm gonna move on to plan B, and I figured out that I can raise the bed all the way up and all the way down with that joint staying here in the gap between the two pulleys, so it never has to interface with any pulleys. Because that's the case, I can join these two pieces together with a bulkier 3D printed part, for example, and I don't have to worry about it having to run over the pulley because it's just gonna stay in the gap between the two pulleys. I went into Fusion 360 and I designed this part that uses an M3 bolt to kind of clamp two pieces together, and that will make the joint that I need. Let me show you what I mean. I can feed one side of the belt through this slot here, and I even designed little teeth to grab on to the belt on the bottom side. Then I can take the other side of the belt, slide it in, then I can put in the screw. All right, and then the nut gets captured in that back piece and will hold it in place. Hopefully I didn't introduce any twists into the belt during this process. So there's my belt clip. Now I can make sure the belt is all routed the right way and tension it up.
It's all or nothing. It's all or nothing. It's all or nothing.
It's been over a month since the last time I worked on the laser cutter. I got sick for like 2 weeks straight, and then I went on vacation with my family. And so it's been a while since I worked on the laser cutter, so I'm trying to get myself back up to speed to see where I left off. The last thing I wanted to do on this bed was to add honeycomb. Now this is one of the big problems I've run into with building a machine this size. I've had a really hard time finding a honeycomb that will fit this machine. The one I did find cost like $200, and then it was gonna cost an additional $400 to have it shipped. and I was not going to spend that kind of money just for the honeycomb. So what I ended up doing was ordering some smaller honeycomb beds that I found on Amazon, and I'm gonna have to piece 6 of them together to cover that area. The cost of the 6 smaller honeycomb beds was about $300, which is more than I wanted to pay, but it's better than paying $600 for one. While I wait for those honeycomb beds to arrive, I'm gonna move on to tackling the electronics. My plan is to build like a control panel where I can screw down all the different parts and then run wires neatly between them. I have everything pretty well labeled, so I'm gonna start removing those components and trying to lay them out on my control panel. Once I'm happy with the layout, I'll start drilling holes and securing them to the control panel. As I'm running power to all of these components, there are a couple of them that I don't want running all of the time. For example, the exhaust fan as well as the air compressor for the air assist. I only want those running while a job is running. In order to do that, I've modified this little extension cord to include a little relay. The laser controller will turn on this relay when a job starts and it'll turn it off when it's finished. So that way the exhaust fan and the air assist aren't running all of the time. The most important thing to note with this relay is that it's only rated for 10 amps, so I have to make sure that anything I plug in here combined will not exceed that 10 amp rating. I just looked at the labels on the exhaust fan as well as the air compressor, and each of them will draw about 1 amp, so I should be safe there. Did I ever tell you of the time I made a video early on? It was the first Sonoff Wi-Fi switch that I made, and it was one of my early videos, and it was actually the first one that kind of really hit it big. And I got roasted in the comment section about not using these ferrules on the ends of my wire. I was told repeatedly that my house was going to burn down and that I was the biggest idiot and that I was going to basically blow up and explode because I hadn't put on these little ferrules. The funny thing is, the electrical breakdown of air is like 30,000 volts per centimeter. So like these two contacts are like 1 centimeter apart. So I'd have to have like 30,000 volts to create an arc and cause a fire, which obviously this is not 30,000 volts. This is only 120 volts. So anyway, a bunch of experts in the comment section thought my house was going to burn down, and yet here I am, house is not burned down. But I do think that these ferrules make everything nice and clean, and they're kind of fun to put on, so that's why I have it. Not to please those people in the comment section, but just because I think they look nice. This electronics control panel is at a point now where I'm ready to put it back inside the base cabinet. Hopefully this fits for the first time and I don't look like a total idiot trying to put this in. Hey, not too bad. The nice thing about this is that it's all on one panel and I can just slide it out, work on it, and then push it back in. I even thought about putting like some drawer slides on there to make it easier to come in and out, but I probably won't work on it that often to justify installing the drawer slides. Now I just gotta plug all of these loose cables into there and then tidy everything up with zip ties. I connected all of the cables back to the components on the control panel and I fired it up and everything still works. I even tested out the exhaust fan as well as the air compressor with that relay, and that worked perfectly. Now the wires didn't clean up as well as I had hoped because some of them I cut a little extra long because I didn't know how long they needed to be. If I was going to clean it up anymore, I'd have to measure and cut all of those wires a little bit shorter and recrimp all of the connectors on there, and that's just more work than it's worth. It's going to be hidden in the back side of that base cabinet and no one's ever going to see it. I got a notification that the 6 honeycomb laser beds should be delivered today, but they're not here yet. In the meantime, I'm gonna move on to building a lid for this laser cutter. I got some hinges and some handles and even some gas struts to help hold the lid open. But if they turn out to not be strong enough, I'll have to order another set. My plan for this lid is to build sort of a rectangular frame that hinges along that back rail there and lifts up. And I wanna be able to mount this display on the front, but I don't want it to interfere with that lid. So I'm going to build in a little fixed section here where I can mount that display, but it's separate from the lid. One of the things that I need to do to take this project across the finish line is to put some panels in to enclose the machine. Right now it's just an aluminum frame full of holes, and that's not very safe because the laser can just go anywhere it wants. So I'm going to enclose it using some aluminum composite material. I originally got some cheap plywood to do this part of the project, but once I discovered this aluminum composite material, it was clear that this was a much better choice. The core of this material is made out of a high density plastic, and then the surface is covered in a thin layer of aluminum sheet on both sides. This material is just the right thickness to slide into the slots in the aluminum extrusions. I even added a little cutout so that my fasteners don't interfere with the panels. I ordered these parts from Send Cut Send, so now I need to take apart the machine and install the panels. I'm really not looking forward to having to take this thing apart. Obviously, I put a ton of work and a lot of hours into putting this machine together, and I'm designing this as I go, so one of the drawbacks of doing it this way is that I have to backtrack and take things apart sometimes. So what I'm gonna have to do is loosen all of these little fasteners that I've put in, and then I take off the bottom and then slide the panels in. Once I get the panels installed, I'm not really sure how I'm gonna fasten the bottom piece on again because these fasteners will be covered up by the panels, so I'm gonna have to figure out something. I've got a couple of ideas in mind, but I'm really not sure if they're gonna work. But I'm at a point where I can't move forward and put these panels in without taking it apart. So I think I just need to stop stalling and start unscrewing. Well, I think I've separated the two halves, but they're still in pretty big pieces, and I don't really have a great way to hold up the upper piece. My two options are like hang it from the ceiling or like prop it up from underneath. I wish I had a hoist right now or like a snatch block, but I don't have any jack stands or anything to prop it up from underneath, and I also don't have like a snatch block or a pulley or something to hold it up from top. So I'm gonna have to think a little bit more about what I'm gonna do next. Here I am kind of shimmying this thing around, and I'm getting really nervous about breaking this tube. It's like a $500 laser tube. So I'm gonna do the smart thing and take out the laser tube and put it safely off to the side and keep working on trying to solve this problem. I dripped some water back there as I was draining the laser tube. It got on the floor, so I had to mop it up with the towel. So sad. Can I be real with you for a second? I've never understood why people think that's so satisfying. Just rip it off and go. Move on with your life. I'll tell you what's not satisfying is having to rip off all this protective film on like 20 or 30 different pieces and throwing it all away. I just finished installing the front panels and I think they look awesome. Now that I've established my process, I think the other sides will go much quicker. Well, you can clearly see I screwed up on the dimensions of those back panels. I didn't measure correctly in my model or something when I ordered the panels, and they're oversized luckily, so I think I can just kind of trim them down and maybe notch out the little pieces that I need for those little 90-degree internal fasteners, and I think we'll be back in business. just woke up, so I probably look really tired. I stayed up late finishing all of the black panels on the laser cutter, and I have to say I'm really excited with how it's turning out. I ended up having to take apart pretty much the whole machine. I had to take apart the bed and the bottom half and disassemble it pretty close down to where I started from just to get those panels in. But I think the result was worth all of that extra effort. I mean, I was literally picking it up and moving it around, so I'm certain that it has come out of square. So I'm just gonna take a quick measurement. And it looks like I'm off by only like 3 or 4 millimeters, so that's pretty dang good. I can just inch it back into place, or rather millimeter it back into place. To secure the machine to the base cabinet, I'm just gonna take some of these little metal brackets here and screw them down to the base cabinet. Now I need to reassemble the bed and all the parts that make it go up and down, but before I can do that, I need to solve one last problem, and that's the lid. The lid is one big floppy kind of rectangle, and that's a problem because it kind of droops down and binds up when I try to open and close it, so I'm going to fix that. I've got 3 more pieces of aluminum that I'm going to use to add some triangles into the lid to give it more rigidity. I want to be able to look through the top of the lid to see what I'm working on when I'm using this laser cutter, so instead of using the same black opaque panels that I did on the rest of the machine, I've ordered some translucent gray acrylic. I'm going to install these panels in the lid. You may not be building a giant laser cutter big enough for you to fit in, but I'll bet you have a project that you've been working on for a long time or wanted to get started for a long time. I think it's a shame to leave those creative ideas unfinished and floating around in your mind. I'm here to encourage and inspire you to get those projects started and across the finish line. I'm going to talk about something that's kind of a little bit hard for me to talk about. Earlier this year, I lost one of my sponsors, and it was kind of a wake-up call for me. It's awesome to work with brands and companies that want to sponsor my channel, but as I learned earlier this year, it's not always reliable. Right now, channel memberships and Patreon only account for a small portion of my income, and I would love to increase that. Sponsorships may come and go, but income from channel memberships is much more reliable in the long term. And I would love to keep working on projects and sharing them with you. I'm not going to ask you to like this video or subscribe or smash any notification bells. I just want you to sincerely consider the value that I'm offering here, and if it's something you're able to do, become a channel member, and that would help me out a lot. By far, my favorite reward is the Discord community. Like I said earlier, my goal is to help you get started and finish those projects that you have sitting in that box in the corner, and the Discord server is an awesome way to do that. We have people post what they're working on and asking questions and getting help there. Even if I don't know the answer or can't help you, there is likely somebody else there that can. All right, I gotta get out of this machine and start editing this video so I can post it to YouTube.